Today, I'm going to show you how to use the camera module within a React Native app. We'll use the camera to take a profile picture, and to recognize text via OCR to search a word definition. We will also perform I/O operation within the apps. Welcome back to Just Code China. Please support us by subscribing to our channel and like our video. If you have not watched our last tutorial video, please do so by click on the link provided below. If you have any question in this tutorial, please leave a comment below. Today's tutorial, we will continue to modify the dictionary app we had created in the past tutorial to illustrate how to use the device camera and I/O features. We will modify the existing rover navigator to allow user to click a button to take a profile photo and save the photo in the device storage. We will also modify the existing search page to allow the user to input text for searching via the camera OCR. Before we start coding, we need to install a few more npm modules required by the new feature we are going to build. Let's bring out our terminal screen. Make sure you are in the project root folder. The first module we're going to install is the React Native Camera module. Just type yarn add React Native Camera and press enter. The most detailed parts in React Native development is to install native npm module that requires special setup steps. The installation had completed. Let's bring out the VS Code with the project folder open. In the iOS info.pdis file, specify the camera usage as shown. This is to indicate to iOS that the app was using the camera features. Next, open the Android manifest.xml file under the Android folder and add in the following permission. This permission allows the app to use the camera features in the Android environment. In the Android app build.gradle file, insert the missing dimension strategy setting under the default config block. If we are only using the camera to take photo, then what we have done so far is sufficient, and we can proceed to code. However, we also want to use the camera to perform optical character recognition, OCR. Therefore, we have additional steps to perform. We need to enable the MLKit from Firebase to use the OCR features. Let us first configure MLKit for iOS. In the iOS port file, add in the port config for the camera module with text detector as shown. Save the port file and run port install via the terminal screen. After port install complete, we need to set up a project in the Google Firebase Console. Let's browse to the Firebase Console in the browser. You need to have a valid Google account to access the console. In the Firebase Console, click on the Add Project button, enter the project name. You can use any name, but be meaningful. For this example, we'll enter Just Code DICT and click on the Continue button. Accept the default setting and click on the Continue buttons. Choose the Google Analytics account from the drop-down list. If there is no existing account, then select Create a New Account option. For now, we will select Google Ads account and click on the Create Project button. Firebase will now create the project. Let's wait for the process to complete. Once the process complete, click on the Continue button. On the project page, click on the iOS icon to add an iOS app. Key in the iOS bundle ID. We will leave the rest of the field empty and click on the Register App button. Download the Google Service info.pdis file. Open up the JustCode.dict workspace in Xcode and the folder where the download file located. Drag the Google Service info.pdis file from the folder to the Xcode application folder. Add in port Firebase core in the iOS port file and run port install. In the iOS app.dedicate.m file, import the Firebase header file and call the FIR app configure method in the did finish launch with option method. Next, we will configure the MLKit for Android. First, we will modify the missing dimension strategy under the default config block in the Android app build.gradle file by changing the general to MLKit and save the file. Now, bring out the Firebase Console browser. Click on the Android button to create an Android app. Key in the Android package name as shown and click on the Register App button. Click on the Download Google Service.json button. Copy the downloaded file to Android app folder. In the Android build.gradle file, add in the class path for Google Service under the dependency block as shown. Now, open the Android app build.gradle file and add in the implementation in the dependency block as shown. In the same file, scroll till the end of the file, add in the Apply Plugins setting as shown. Now, open the Android manifest.xml and add in the metadata tag under the application tag as shown. This will enable automatic download the ML model to the device after the app is installed from the Play Store. We have almost done with the camera module. However, with the camera module installed, the app for Android will generate the class file that exists the maximum 64K methods allowed. To overcome this issue, we need to enable multi-dex class file in Android. To do that, we need to add in a setting multi-dex enable under the default config block in the Android app build.gradle file as shown. Then, in the same file, at the dependency block, add in the implementation for multi-dex as shown. Now, open the main application.java in the Android folder. Replace the extend application to multi-dex applications as shown. Save the main application.java file and clean the Android build file by the gradle clean command as shown. The next module we're going to install is the React Native File System module. In the terminal screen, key in yarn add React Native FS and press enter. Once the installation complete, open the iOS port file and add in the port config for RNFS as shown. In the same port file, scroll to the Add Flipper port blocks. Change the Flipper version to 0.37.0. This change is to fix the image component bugs when displaying base64 image in iOS. Now, let's run the port install command to complete the installation for the module. We have completed all the module installation. To verify MLKit in Firebase is set up correctly, now let's bring out the Firebase Console. In the Firebase Android app page, click on the item 4. you will see the status of the installation. Now, let's run the JustCode DICT in the Android device. Once the app runs in the device, the Firebase Console will update the status as successful. Close the Android app page in the Firebase Console, select the iOS app, then click on the item file to verify the setup. Now, let's run the JustCode DICT in the iOS simulator. We will see the Firebase update the status as successful. We have verified the MLKit setup in Firebase for the camera modules. Next, we will start modify the source code to add in the camera features. First, we will create a custom component to wrap around the React Native camera module. Let's bring up VS Code and create a camera folder under the source components folder. Under it, we will create a index.js file. At the beginning of the file, we will import all the required modules, including the RN camera module. Followed by, we will export the RN camera constant. The three dots in front of the RN camera tell the compiler to destructure the RN camera constant object. Next, we will create a camera class component. Let's leave the component structure empty first. We will proceed to define the component prop types. The first property will be the camera type, with the prop type set to any. This property indicates which camera, front or back, to be used in the app. The next property is the flash mode, and it is also set to prop types.any. This property will turn on and off the flash, or set the flash to auto. Followed by is the autofocus property. It tells the camera to turn on or off the autofocus features. The white balance property tells the camera to use which white balance profile built in the camera. You can set the white balance to sunny, cloudy, shadow, fluorescent, or auto. The ratio property tells the camera to save the captured image into the ratio defined in the property. It is a string prop types. For example, we can have 1:1, 4:3, or 16:9 ratio. The quality property tells the camera to save the captured image in a specific quality. It is a numeric value. The range will be from 0 to 1, where 0 is the lowest quality and 1 is the best quality. The image width property is used to set the width of the captured image. It is a numeric type. The height of the image will be automatically calculated based on the ratio. The style is used to set the style on how the camera to display, and it is an object type. The onCapture property holds the method of the camera components to call back when it captures the image. This method will accept two parameters: the data parameter that contains the base64 image. The recognized text parameter will contain the recognized text when enable OCR property is enabled. The last property is the onClose method. It is used to perform a callback to the decoder when the user closes the camera without taking a picture. Now, we will set the default value for all properties. First, we will set the camera type default to back camera. Then set the flash mode to off. We will set the autofocus to on, white balance to auto, ratio to 4:3, quality to 50%, image to 768 pixels, style to null, onCapture to null, enable OCR to false, and onClose to null. Next, we will define all the style required by the camera's component. We will not go into detail on the style definition. Let us scroll back to the camera class component. We first define the camera object variable to hold the RN camera object reference by setting its initial value to null. Next, we will define the component state. The state will consist of the camera tabs, flash mode, and recognize text object. You might ask why we need the camera tab and flash mode state, since we already have the camera tab and flash mode property. The reason is the user can change the camera tab and flash mode within the component. Therefore, we need to have a state to hold the value. We will initialize the default value for the state as shown. Followed by, we will define the component mount method. Within the method, we will set the camera tab and flash mode state to the value passed via the property. Now, we will define the render method for the component. We will create a view as the component container. Within the container view, we will insert the RN camera component. In the RN camera component, we first assign the component reference to the camera class object variable. We will need to use this reference data to take picture. Next, we will set the style, camera tab, flash mode, ratio, capture audio, autofocus, white balance, permission option, and the on-text recognize method. We will set the capture audio to false as we don't need the audio for taking picture or recognize text. The on-text recognize property hold the callback method if the enable OCR is enabled. This is to receive the recognized text whenever the camera detects text in the image. Under the RN camera component, we will create a view to hold the flash mode toggle button, a capture button, and a camera tab switch button. The flash mode toggle button will toggle the flash mode from off to auto, auto to on, and on to off again. The toggle button image will change accordingly to the current mode. The capture button will fire the take picture method to take a photo. We will define take picture method in a short while. The camera tab switch button will only be displayed when the enable OCR is false. This button toggles the front and back camera alternatively. Last but not least, we will create a button to allow the user to close the camera without taking a picture. Now, let us define the take picture method. We will define it as an async method. First, we check if the camera object variable is linked to the RN camera reference or not. If the camera variable is defined, then we will call the camera take picture async method by passing in the option that control the quality, width, and the other setting. Once we receive the camera data from the take picture async method, we will call the onCapture callback method if defined, passing in the base 64 image and the recognized text state. The next method we need to define is the onText recognize method. This method will receive the recognized text object via the data parameter. This method will set the data into the state only if enable OCR is true and the data text block contains the recognized text. We have completed the camera custom component. Let's start to modify the existing app to allow the user to take a profile picture. Open up the app.js file and import the camera components and the React Native File System module, RNFS. In the app component, we will define the show camera and profile photo state. The show camera state is used to decide to show the camera module depending on the user action. and the profile photo state will hold the user profile photo. The profile photo can be the default icon.png file or a file captured by the camera. Next, we will define the component dipmount method. In this method, we will check is there any file with the name profilepics.png that exists in the document directory path using the rnfs.exist method. If it exists, then it will read the file content using rnfs read file and update it to the profile photo state as the object with the URI property. This is the object required by the image component to display the base64 image. Followed by, we will define the save profile photo method. This method will save the base64 image returned by the camera into the device storage. It first defines the path of the image to be saved. Then, it will strip off the base64 image prefix in the data parameter, if any. It will call the rnfs write file method to save the image data into the path specified. Once the file is saved, it will update the profile photo state with the image data. In the render method, we will add in the camera component that will display only if show camera state is true. Since the camera component is for taking profile photo, therefore we will set the camera tab to front camera. We will set the flash mode to off, autofocus to on, white balance to auto, ratio to 1:1 so that it is suitable for the profile photo. We will also set the quality to 50%, image width to 800 pixels. We will set the on-capture event to the save profile photo method we had defined just now. Next, we will define the on-close event to set the show camera state to false when the user closes the camera without taking a photo. Now, we need to add a trigger in the UI to allow the user to bring out the camera. We will add a camera button beside the profile photo. Let's scroll to the drawer content functional component. We will create a view to wrap around the existing image component. We then change the image source from icon.png to the profile photo property. Below the image component, we add in a touchable opacity component. Within it, we will add in the icon component. In the touchable opacity on press event, we will call the toggle button method from the props, which we will define later. This toggle camera method will change the show camera state in the apps component so that the camera component will show up. Take note of how we write the code to call the toggle camera methods. The first part is to check if the props.toggleCamera is defined or not. The second part will invoke the props.toggleCamera method if the first part is true. This is a shorthand way of writing the code, instead of using the if-else statement. Since the drawer content is used by the drawer NAV component, and it expects to have the profile photo and toggle camera properties. Therefore, we need to modify the drawer NAV component to pass in the two properties from drawer NAV props. Drawer NAV acts as a proxy when passing the profile photo and toggle camera properties. Therefore, we need to make sure these two properties are available when drawer NAV is invoked. Let's scroll to the render method of the app components. We will define the toggle camera method to toggle the show camera state as shown. Next, we will assign the profile photo property to the profile photo state. What we have done so far is to change the show camera state in the app class component when the user taps on the camera icon in the drawer container functional component. Since app, drawer nav, and drawer content are different components, therefore, drawer content component cannot directly set the show camera state in the app component. That is the reason why we need to pass in the toggle camera method recursively now to the drawer content component. This is one of the major drawbacks when using component state with a deeply nested situation. Luckily, we have React Redux come to the rescue, which I will cover that in the future tutorial. We have completed the coding for changing the user profile photo. Now, let's run the app in the Android device, and I will step into the code to let you see the logic flow. In the VS Code, let's place a few breakpoints in the app.js and camera index.js file. Now, we will debug the application using VS Code. Select the Debug Android option and wait for the application to run in the Android device. Once the app launches in the device, we will see that the breakpoint in the component didMount method will be fired. Press F5 to run to the next breakpoint. You will see the file does not exist, therefore it will skip the read file method. Now, bring out the side menu in the app and tap on the camera button. The breakpoint in the drawer content component will be fired. If we press F5, then it will fire the toggle camera method defined in the app render method when invoking the drawer nav as shown. It will then toggle the show camera state. When we press F5 to continue, the camera component will display. Let's take a selfie as the profile photo by tap on the shutter button. The breakpoint in the save profile photo method will be fired. It will get the path to save the photo. Press F5 to continue, and the next breakpoint will hit. At this stage, the photo has saved into the device storage successfully. Press F5 to update the state with the image data, and the selfie we just took will appear in the profile photo. Now, let's reload the application to fire the breakpoint in the component didMount method again. Press F5 to execute the rnfs.exist method. The exist variable will be true, and this means that the profile photo exists in the system. We will press F5 again to read the profile photo via rnfs read file method. We can see the buffer variable will contain the profile photo base64 image data. Pressing F5 again to update the profile photo state. Bring out the side menu again, and we will see the profile photo display the selfie we have took earlier. We have completed the profile photo features in the app. Next, we will modify the existing search page to use the text recognition features to input a word to search. Before we make any change in the search page, we need to create a custom component to allow the user to select a word from a list of words written by the text recognition. First, create a word selector folder under the components folder, and then create the index.js file. Let's import the required modules at the beginning of the file. Then, we will create a class component named wordSelector. Before implement the component, let's define the component's properties and styles. We have the word block property to allow the caller to pass in the word block object written by the camera module. The onWordSelected property is a callback function when the user selects a word. Now, we will define the initial state for the word selector component. We will have the selector word index and word list state. The selector word index state keeps track the word index the user has selected. The word list state will store an array of words converted from the word block property. Next, we define the component deepmount method, which will convert the word block property to a single dimension array and update the word list state. Followed by, we will create a populate words method to return a list of touchable highlight components that contain each word in the word list state. Each of the touchable highlight components will handle the user onPress method to update the selected word index state based on the word the user has selected. In the render method, we will display a prompt for the user. Call the populate word method to display all words and wrap it in the scroll view component. At the end of the screen, we will press an OK button for the user to confirm the word selection. Once user taps on the button, it will perform a callback via the onWord selected property. Next, we need to modify the existing search index.js file to use the camera and word selector to perform word input for searching. We'll begin by importing the camera and word selector module. Then, we will modify the existing state to add in show camera, show word list, and recognize text state. We will add in the onOCR capture method to handle the camera component's onCapture event. In this method, we will update the state to hide the camera, show the word selector component, and update the recognized text state. The next method we're going to add is the onWord selected method. It will handle the word selector component onWord selected event by update the user word state and hide the word selector component. It will then wait for 500 milliseconds to fire the onSearch method to perform a word search. The reason to wait for 500 milliseconds is that the state takes time to update. So, if we fire the onSearch method without waiting, then the user word state might not contain the word to search yet. Now, we will modify the text input component by adding a touchable opacity component and wrap it with a view component. When the user taps on the touchable opacity component, it will update the show camera state to show the camera component. Next, we add in the camera component after the save area view component. The camera component will only display if the show camera state is true. We also assign the onOCR capture method to onCapture event. In the onClose event, we will update the show camera state to false. Followed by, we will add the word selector component by passing in the recognized text state to the word block property and assign the onWord selected event. Finally, we will update the styles definition. We had completed all the changes and let us save the files. Before we step through the code, let's remove all existing breakpoints and place new breakpoints in those files we have just modified. Now, tap on the camera icon in the app and take a picture with whirling. The onOCR capture method will be fired, and we can see the recognized text contain the complex data structure. Let's press F5 to continue, and the populate word method in the word selector will be fired. However, the component is not yet mount. Therefore, the populate word will return an empty array. Press F5 again and the component deep mount will be fired. The component deep mount will break down the complex data passed by the recognized text to the word block property into a single dimension array as shown. Press F5 again and populate words will fire again. However, this time we have the word array in the word list state. Press F5 to go to the last line of populate word method. We will see the word view array contain a list of touchable highlights components objects to be returned. Press F5 again and the word selector will appear with a list of words for the user to select. Tap on the word in the list and you will see the OK button become enabled. Tap on the OK button and the onWord selected method will be fired. It receives the selected word via the word parameter as shown. Now, press F5 to continue the execution. The word selector component will be hidden and the search page will perform the word lookup via the Optics API. We have come to the end of this tutorial. Today, I will show you how to install and set up React Native Camera and File System module, how to use the modules to take a profile photo, perform text recognition, and I/O operations. If you have any question regarding this tutorial, please feel free to leave a comment below. You can follow the link to get a workable source code for the app in this tutorial on our GitHub page. Don't forget to change the Oxford API app ID and key to yours and generate your own Firebase config file for iOS and Android. If you find our video useful, do support us by like our video and subscribe to our channel. And don't forget to click on the notification bell. Thanks for watching. Bye.